Alright, the first test we're going to talk about is the geometric series test. It leads straight from where we were just talking in example 3 about multiply pattern. So a geometric series is just that. It's a multiply pattern, and it can be written exponentially. So when we look at these and we see where n or x would be the exponent, that's going to let us know that it's a geometric series. And what we just talked about is if the thing that it's multiplying by r, it's called your common ratio, the thing it was multiplying by, if that is greater than 1, that means this series is growing. It's getting bigger. So all those fractions we saw were getting bigger in example 3. So that's because that ratio was bigger than 1. If the ratio is less than 1, then it's going to decrease to 0. And so what that means is it's going to then converge. And so what we know for sure is if it's converging, then it's going to converge to this. So we've got that first term and then 1 minus r. So we're just some examples with this in problem 4. We have A, B, and C. Some of them we're going to require a little bit of manipulation so that we can write them and just identify exactly what the series part is, the geometric series part. So notice in example 1a that 3 is not part of the exponent thing right there. So we're going to rewrite this as 3 times 1 over 2 to the n power, which then we can turn around and write 3 times, I'm thinking this is like 1/2 whole thing to the n power. I want to do that because that 1/2, that is my r. So since we know that 1/2 then is definitely less than 1, then we're going to say this thing is going to converge. And no point in doing the long work with the limit because there was a pattern to how they converged. So the first term, if n is 1, is 3/2. So that's my numerator, 3/2. And the denominator is 1 minus that ratio, so 1 minus 1/2. So that's going to turn into 3/2 over 1/2. And they have that same denominator right there. So it looks like that's going to converge to 3. All right, let's look at B. We actually did B in example 3. That common ratio, 3/2 is greater than or equal to 1. So this thing is growing. So that means it's going to diverge. Sometimes you'll see where we say like what test we use. We're going to do a lot of tests in this unit. There's 10 of them we're going to do. So you might want to write like by whichever test is doing. GST, Geometric Series Test, is the one we're looking at right now. All right, be careful with C. C, first of all, says it starts at 2. So that's something we got to pay close attention to when we figure out what our first term is. And then this is why, so that's a negative 1/2. So that's why we have these absolute value bars. So the absolute value of negative 1/2 is certainly less than 1. So even though this is going to change sign plus or minus, it is still going to head down to 0. So we're going to say this thing is going to converge. And we need to figure out converge to what. So our first term in the sequence is going to be when I plug in 2. So I'm going to plug in 2. I'm going to get 3/4 for my numerator. And my denominator is 1 minus that ratio. Well, that ratio happens to be negative 1/2. So now I'm going to simplify this. So I have 3/4 over 3/2. We might want to rearrange this. So I have 3/4, now I'm going to say times 2/3 like this, so that I can simplify. And it looks like I'm going to end up with 1/2 is what this is going to converge to. So that is our geometric series test. It's pretty easy. It's one that comes up a lot. So we're going to be using this for the next several weeks. And we will look at our next test.